Hey students, welcome back. Let's start the paper 4 of May-June 2024, variant 2. Let's start it. Question number 1. A list of gases is shown. So we have been given these gases: ammonia, helium, hydrogen, carbon dioxide, carbon monoxide, chlorine, methane, nitrogen dioxide, propene, and sulfur dioxide. Answer the following questions about these gases. Each gas may be used once, more than once, or not at all. State one gas which is the main constituent of natural gas. So one gas which is the main constituent of natural gas is methane. So the answer is methane. Next, which gas is responsible for both photochemical smog and acid rain? And I guess it's nitrogen dioxide, which is responsible for photochemical smog and acid rain. Then, which gas is unsaturated? I guess the unsaturated one is propene here, because in propene there is a double bond, which means it's unsaturated. So it's propene. Which gas has monoatomic particles? Monoatomic particles means one atom, like the gas which exists as one atom. And they are halogens. So we have helium, or all the halogens, they are gases which exist as one atom. They are monoatomic. Next one, the gas which reduces iron oxide in a blast furnace. So in a blast furnace, we have iron oxide, Fe2O3, and it is reduced by carbon monoxide. And after reduction means the removal of oxygen. So carbon monoxide removes the oxygen from iron oxide, and in turn, it gives two atoms of iron plus carbon dioxide. So here, the reducing agent is carbon monoxide. Next question, nitrogen dioxide and carbon monoxide are removed from a car exhaust by catalytic converter. Write the symbol equation for this reaction. So a symbol equation for the catalytic converter is NO2, nitrogen dioxide, which is formed inside the engine due to the high temperature, and we get carbon monoxide because of incomplete combustion when they react with each other. Again, the carbon monoxide acts as reducing agent and it reduces nitrogen oxide. It removes the oxygen. It removes oxygen from nitrogen dioxide, and nitrogen dioxide will form nitrogen gas. Plus, this carbon monoxide converts into carbon dioxide. When we want to balance this equation, as we can see that this nitrogen is 2 on the product side, so we'll write 2 here on the reactant side to balance it. It makes oxygen 4 on the reactant side, so to balance the oxygen, we'll write 4 here and 4 with carbon monoxide. This equation is now balanced. Next question, a list of 5 elements is shown. We have copper, iron, magnesium, potassium, silver. All metals form positive ions, right? It's correct because all metals lose electrons. And when they lose the electrons, they get a positive charge. Describe how atoms form positive charge by the loss of electrons or by losing electrons. State which of the 5 metals in the list has the greatest tendency to form positive ions. The metal with the greatest tendency to form positive ion will be the one with highest reactivity. So out of these 5, potassium is the highly reactive. It has the highest reactivity because it is present in group 1. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. It is not likely to show catalytic properties. Catalytic properties are shown by transition metals. From these, copper, iron, and silver, they are transition elements. So magnesium and potassium, they are the ones which are not likely to show catalytic properties. So you can write any one, potassium or magnesium. Which of the 5 metals in the list is a major component of stainless steel? Obviously, the stainless steel is made up of iron. It's an alloy of iron. Next question. A student adds a sample of a metal to an aqueous metal salt in a beaker to see if a displacement reaction takes place. A student adds a sample of metal. For example, there is a metal X, and a student is adding a metal X to an aqueous solution of metal salts. So we have any other metal salts like Y chloride or Y bromide or Y iodide or Y sulfate. So we have two metals over here. We have X and Y. These are the two metals. So let's see if the metal X can displace metal Y from its compound or not. We have magnesium, and magnesium is added in iron sulfate. So if the magnesium is more reactive than iron, so it will displace it. And yes, magnesium is more reactive than iron. So in the starting, the solution will be green. It's written it's green because of these iron 2 ions. The iron 2 ions are green in color. So because of iron 2, the solution is green. But after the reaction, when the magnesium displaces iron, it forms magnesium sulfate, which is colorless. So it will change from green to colorless. Next, silver is added in a solution of copper sulfate. Now, if we compare the silver and copper in the reactivity series, so randomly there will be magnesium, potassium, sodium, magnesium. In the middle there is calcium, then aluminium, zinc, iron, nickel, lead, copper, and then there is silver. So in this reactivity series, as we can see that copper is more reactive and silver is less reactive. So silver will not displace copper. So the solution will be blue in the starting, and in the end also it will remain blue because no reaction will happen. Most group 2 metals form a gas when placed in cold water. An alkaline solution is also formed because group 2 metals are called alkaline earth metals. So these metals also form alkaline solutions like group 1. Name the gas formed when strontium is added to cold water. Now, when strontium is added to cold water, it's Sr plus H2O. It gives strontium hydroxide plus hydrogen gas is evolved. So this is the equation. So a gas which is formed is hydrogen gas. Name the alkaline solution formed when strontium is added to cold water. So the alkaline solution will be strontium hydroxide. One group 2 metal reacts very slowly when placed in cold water. So this one will be less reactive. When heated, the metal reacts with steam to form a white solid. Identify this metal, identify and name the white solid. Now in group 2 metal, group 2, then some of the metals are low reactive. In group 2, we have beryllium, magnesium, calcium, strontium, barium, and radium. These are the elements of group 2. Now, in group 2, as we go down the group, the reactivity increases. So the elements like beryllium and magnesium, they are low reactive as compared to the other elements of this group. Here, the metal which forms a white solid is magnesium. So magnesium forms a white solid which is magnesium oxide. Because when it reacts with steam, it forms magnesium oxide, not the hydroxide. Under certain conditions, iron will react with steam to form an oxide of iron with the formula Fe3O4. Fe3O4 reacts with hydrochloric acid to form a mixture of iron 2 and iron 3 salts and water. Deduce the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid. Now, it's clearly written in the question that when Fe3O4 reacts with hydrochloric acid, it gives a mixture of iron 2 and iron 3 salts. So it means it is giving FeCl2 and FeCl3, both. So if we write the symbol equation for this reaction, then it will be Fe2O3 plus HCl gives FeCl2 plus FeCl3 plus water. Now, to balance this equation, we'll see how many chlorines are there, how many oxygen, and how many iron. Now, iron, it will be Fe3O4. So here, as you can see on the reactant side, there are 3 iron. So to balance the iron, we'll write 2 on the product side with FeCl2. This makes chlorine 8. Here in 2 FeCl2, the chlorine will be 2 into 2, 4. This 2 will be written with FeCl2 and this is FeCl3. And this 2 will be written with FeCl3. 2 into 3 becomes 6 plus here the chlorine is 2 which makes total 8. So to make 8 on the reactant side, we'll write 8 here with HCl, which makes hydrogen 8. So to balance hydrogen 8 on the product side, we'll write 4 with H2O. This makes water 4. And our equation is balanced. The symbol equation for the industrial production of ammonia is shown. N2 plus 3H2 gives 2NH3 and the delta H is given to us which is in negative 90 kilojoules per mole. Name this industrial process. So this process in which ammonia is prepared is known as Haber's process. State the meaning of the term delta H. It's called enthalpy change. State the typical conditions and name the catalyst used in industrial production of ammonia. So the industrial production of ammonia, the temperature which we use is the optimum temperature of 450 degrees Celsius. This temperature is not too high, not too low. The pressure which we use is 200 atm, or if we write it in kilopascals, then it will be 20,000 kilopascal. This much high temperature is used in the production of ammonia and to keep the system towards right. Then the catalyst which we use is iron, Fe. State 2 methods of increasing the rate of this reaction. Now, to increase the rate of this reaction, which is the production of ammonia. As you can see, they are all gases. And for the gases, we can write that by increasing the pressure, we can increase the rate. Because pressure only affects the gases. And also by increasing the temperature, we can also speed up the reaction. Next part, the simple equation for the reaction can be represented as shown. For the same Haber process, same production of ammonia, now they have given us the equation in the form of like showing all the atoms and all the bonds in the displayed structure. So we have N2, this is N2 plus 3H2, 3 hydrogen bonds. It gives us 2 ammonia. And as you can see, there are 2 ammonia molecules. The bond energies are given to us. The bond energies for N bond and HH bond is given. Use the bond energies in table 3.1 and delta H to calculate the bond energy of an NH bond. The delta H is given to us in the question, which is minus 90. Now we will use this delta H and the bond energies of N2 and H2 to calculate the bond energy of NH. Let's do it. Calculate the energy needed to break the bonds in the reactants. Now, as for the reactants, in the reactants, there is one N bond, N triple bond end. And as you can see, the hydrogen HH bonds are 3 here. So we will do 3 hydrogen, 3 HH bonds. So if we substitute the values NH 945 plus 3 molecules of HH 435, which gives us the value positive 2250 kilojoules. For the next one, the energy released will be 2 NH3. In 2 molecules of ammonia, there are, as you can see in the structure, there's 1 bond, NH1, 2, 3, 4, 5, and 6. So it means in 2 molecules of ammonia, there will be 6 NH3 bonds. What we'll do here to calculate, these are the reactant energy plus 2250 and the product energy, product bonds are 6 NH. And it will give us positive 2250. The bond energy, the delta H. The enthalpy change is minus 90, the total enthalpy change. So what we'll do to calculate the energy release when the bonds are formed, in the product, we will not write about NH because we'll calculate it in the next step. Right now, we can do plus 2250 and we'll take this 90 on the other side of the equation, so it will be positive. It will add up. And the answer will be 2340. Now, we got the reactants and we got the product also. Now we can calculate 6NH. Now for 6NH, the bond energy is 2340. To calculate it for 1NH, we'll divide it by 6. And we get the answer 390. An incomplete symbol equation for the preparation of ammonia in the laboratory is shown. Complete the symbol equation. Now, we have calcium oxide, ammonium chloride, and calcium chloride. Ammonium chloride. So, when calcium oxide reacts with ammonium chloride, whenever a base or an alkali, whenever it reacts with any ammonium salt, ammonium chloride is an ammonium salt. So whenever alkali and base reacts with ammonium salt, it always gives salt plus water plus ammonium. This is the general equation. So we're getting the salts, calcium chloride, we're getting ammonia, NH3, so we'll get the water, H2O. Name NH4Cl. This is ammonium chloride. Next question is calculate the volume of ammonia measured at room temperature and pressure, which forms 1.12 grams of calcium oxide. So, when 1.12 gram of calcium oxide is heated, what will be the volume of ammonia? Here, we need to understand the mass of calcium carbonate is given to us, and the volume of ammonia is required. We cannot calculate the volume of ammonia if we do not know that what is the mole of ammonia. So to calculate the volume of ammonia, we should know the moles of ammonia first. So what we'll do, from the mass of calcium oxide, we convert the mass of calcium oxide into moles of calcium oxide. Then from the moles of calcium oxide, we'll find out the moles of ammonia by taking the ratio from the equation. So let's do it. The mass of calcium oxide converted into moles will do moles is equal to mass over molar mass. Mass over molar mass. The mass of calcium oxide is 1.12 and the molar mass of calcium oxide is 56, which gives us the value 0.02 moles. Now, to take the ratio between calcium oxide and ammonia, first we'll see from the equation. In the equation, the calcium oxide is 1 and ammonia is 2. So the ratio is 1:2. So if 1 calcium oxide is giving 2 ammonia, then 0.02 of calcium oxide will give how much ammonia? So it comes out to be 0.04 moles. So when we have these moles of ammonia, we can calculate the volume of ammonia by doing moles is equal to volume over molar volume. The molar volume here will be 24,000, which is a fixed value of molar volume if it is in centimeter cube, and we want to find the answer in centimeter cube. So the number of moles are 0.04. Volume divided by 24,000. We'll take this 24,000 on this side of the equation, multiply it with 0.04, and the answer comes out to be 960.